In this video, I really just want to review binary ionic nomenclature. In other words, how we're going to name most ionic compounds. So where we left things off was really deciding what type of bond you have on the inside of your compound. Now, in our previous video, we talked about how to name covalent style compounds. So that's a compound that has any type of covalent bond, whether it's polar or nonpolar. In this video, we'll specifically take a look at compounds that have an ionic bond in between. So they have an electronegativity difference higher than 1.7 between any of the atoms that are inside of the compound. Here are two examples. We have NaCl and Cai2. If you calculate the electronegativity differences between those pairs of ions, you'll find that they're both above 1.7. But how do we name them? Well, we should know that binary really means two. So binary ionic nomenclature means it's how we name molecules, or compounds really in this case, since they're not covalent. Covalent are called molecules. Ionic materials are called compounds. Binary compounds mean that they have only two types of atoms on the inside. Well, NaCl we know and love as sodium chloride, and Cai2 is named calcium iodide. Well, great. But how did I know to name them with or without a Roman numeral? Because remember, when we did learn about nomenclature, sometimes we used a Roman numeral, sometimes we use a prefix, sometimes we don't use anything. How can I decide all of this all of the time and do it well? Well, first of all, you really just need to look at the identity of the first atom inside of the compound. Now, in this case, sodium and calcium both came from this highlighted region on the periodic table. It came from the first two columns, or it was aluminum, zinc, cadmium, and silver. And this region on the periodic table is pretty special. And that's because they have consistent and very predictable charges of their ions. Just based upon where they are on the periodic table, I should always know what those charges are. And here's what they are. In the first two columns, you would have either a +1 or a +2, and then silver always is a +1, zinc and cadmium are always a +2, and aluminum is always a +3. Now, because these atoms constantly have a predictable charge, we never need to include those in the name. So we never use a Roman numeral when these particular elements start my compound. We also have this area on the periodic table. In blue, I've highlighted the transition metals. Now, what makes this group of atoms special is that when they form ions, they have variable charge. Just simply based upon where they are on the periodic table, you actually can't predict consistently well what their charge is going to be. Now, that dramatically affects our ability to crisscross. So in this particular section, we will always need to include a Roman numeral that indicates which specific charge we're using. So let's take a look at two more examples. Here we have CuCl and we have SnI2. And if you'll notice, if I go back a couple pages, both the Cu and the Sn are both from this blue region. Again, the first element in the compound will let me know how to name it. Because they come from this blue region on the periodic table, I need to include a Roman numeral with the charge. So how is it done? Again, the first element tells me the story. Because the first element is a transition metal, I know I need to include a Roman numeral with the charge. Well, this first compound would be known as copper 1 chloride. And again, the 1 indicates the charge of the copper. The second compound would be called tin 2 iodide. The tin indicates the charge of the tin on the inside of this compound. But where did I get those charges from? This is where you need to do a little bit of math. Look up the charge of the element that the metal is connected to, the thing at the end, the non-metal. They'll never lie to you. Luckily, in both of these cases, the charges of the non-metals that they're attached to are both -1. And here's where the math comes in. Don't forget that you're going to multiply that charge by its subscript and get that answer. and then divide by the subscript provided on the metal. And if you don't see one, that means it's a 1. We just typically don't write the 1 there. And then finally, bada bing, bada boom, you will have the charge of your metal. And if you'll notice in both of those cases, the copper had a positive 1 charge, and that's where the 1, the Roman numeral 1, came from. And the tin had a positive 2 charge, and that's where the 2 Roman numeral came from. So just as a review again, based upon where the first element on the inside of the compound falls, this will help you determine what style of nomenclature or naming that you're going to use. If the first element falls inside of your red area here on the periodic table, that would be the first 2 columns, aluminum, zinc, cadmium, or silver, then it's super duper easy. You name the metal, then you name the non-metal, and you just simply add the ending IDE. If the first element comes from this blue region on the periodic table, then you name the metal first, include the Roman numeral for its charge, name the non-metal, and add IDE ending. A good example, again, would be like copper 2 chloride. Finally, if your first element in your compound comes from the non-metal region on the periodic table, well, then you have a covalently bonded compound. This is where you start to use the prefixes. So you would use a prefix, anything except for mono out front, name the first element, name the second prefix, the second element, and add the ending IDE. In all cases, they all end in IDE. A great example, again, would be like carbon dioxide. Now, if your compound tends to start with a metalloid, I promise that I will not give you any of these, but I will definitely tell you that the naming in this section gets a little bit convoluted and kind of wacky. It tends not to really follow any one rule. So because the naming in this section is going to be variable, I am going to avoid giving you compounds that start with elements from this particular region. Now, last little bit here, what I have for you is just a quick little mixed up practice. Now, again, you can determine how to name these compounds simply by looking at the first element on the inside of the compound. I would suggest hitting pause on the video at this point and then resume after you have some answers so you can check your work. All right, now that you're back, let's reveal those answers. So for the first compound, he would be covalent, and it would be called carbon tetrafluoride. The second compound starts with a transition metal, so you needed to include the Roman numeral, and it would be called vanadium 4 fluoride. The third starts with a metal that is in the first 2 columns, so that would be called calcium fluoride. Number 4, again, magnesium comes from the first 2 columns. This is really more of an exercise in crisscrossing. Mg was positive 2, O was negative 2. So when you crisscross them, you also need to reduce that compound, and it turns into MgO. Diboron trioxide, well, that's a covalent compound. The prefixes tell you exactly how many of each of those atoms you need. There is no crisscrossing with these, so it becomes B2O3. And finally, number 6 has that Roman numeral on the inside of it. That's the charge of the iron. You put that in and then crisscross it away, and it becomes Fe2O3. I hope this little review was helpful. You might want to re-watch it just so you can kind of get the feel of this, because these can be very confusing when you have many, many compounds that you need to name all at the same time.